Hello, and welcome to the demo of QuickDoK. This is the login screen where the user needs to enter the username and password. This is the landing page. Here we can see My Projects, All Projects, Start New Project. My Project is mainly relevant for data scientists. It lists all the projects which a data scientist has created, along with the number of experiments that went into developing the project, the status of the latest experiment, performance of the latest experiment, when the project was created, when the project was last updated, and if the project is completed, user can also view or edit the document generated. Then we have all projects. This is relevant mainly for stakeholders like business, compliance, auditor, and others. Here we can see the list of all the projects that are created in the organization. And based on the access control given on the user ID, the users can view or edit the respective projects. Next is Start New Project. The first step is business requirement, wherein we are asking the user to enter the project name. This is a unique and mandatory field. Other fields like business function, business driver, and success criteria are optional. If the data scientist is not aware of these business-related inputs, he or she can skip it, and if they know these details, they can choose to enter so that accordingly it will reflect in the documentation. For the demo purpose, let us fill in some dummy details. Project name as Video Demo. Business function as Marketing. Business driver as Customer Enhancement Experience. And if the user wants to reach the business driver by a success criteria of, say, 20%, then they can enter the value here. Then click on Next. So in the first page, we have given a name to the project. In the second step, we are adding an experiment to this project. Since this is the first experiment, it takes a default name as Experiment 1. User can choose to edit and give some logical name if required. User then needs to add model details to build the model for this experiment. Here we can see a list of machine learning model names. We have few for anomaly, classifier, cluster, regressor, and if there is any model which is not listed here, user can still get the document generated by selecting either Others Supervised or Others Unsupervised, whichever is relevant. For example, the user has built a recommendation model using factorization machine, which is not in this list and is developed on top of TensorFlow or PyTorch. Even then, QuickDoK can document the complete solution using Others Supervised, making it model and platform agnostic. It can be possible that the user has created multi-step solution. For example, the user has developed a two-step recommendation engine. In the first step, user has created a clustering model, and based on the similarity, the customer needs to be clubbed together. And then in the second step, user has created a classification model for recommending products or services to the clustered customers. Hence, in QuickDoK, user can choose to add multi-step model based on the requirement. For demo purpose, we'll go ahead with only one model right now, and we'll select Gradient Boosting Classifier. For the respective model chosen, user needs to select the relevant framework. As already mentioned, QuickDoK supports all the machine learning models and frameworks, so in case the framework used by the user is not mentioned here, the user can choose Others Supervised or Others Unsupervised, and QuickDoK will still be able to document all the details. For the demo, we'll use scikit-learn, since the model developed was built using scikit-learn. Next, the user needs to choose the framework version. QuickDoK supports all the maximum current versions for the selected frameworks, as different data scientists can use different versions. For the demo, we'll select Scikit-learn 0.2 4.1. Then click on Next. This is just a confirmation on the input details. Click on Proceed. This is the most important input page, where the user needs to upload the training file, test file, and model file. Here there are two options for the users to add files. That is either using Upload option or Browse option. With the Upload option, user can upload from their local drive. Through the Browse option, user can add files directly from the data sources. For example, hypothetically, the data for the user is residing in a public cloud file storage. So in this case, user can directly fetch the files from respective storage. Similarly, if the user has a model registry file, the same can be directly fetched using Browse option. For the demo purpose, I will use the Upload option. I'll upload some dummy file. It should be in CSV format. Similarly, I'll upload a dummy test file and then model file. One interesting point to mention here is that user need not wait till the upload is completed on this page, because it is possible that the data size of the file is huge, say 100 plus gigabytes. So even while uploading is in progress, user can continue to go to next page, and everything is taken care of at the back end. Here we have also kept an option for the user to enter metadata specific to training and test data. This is an optional step, and it's kept only for documentation purpose. The user can enter the date range of the data in the training file, the source of the data file used, and the respective table from the data source. Similarly, we have the metadata for test file as well. Then click on Next. This is the input summary page, where it gives a snapshot of all the inputs entered by the user for this project. If the user wants to edit any part, they can click on the edit icon and change the desired field. For now, I'll click on Next. Data validation is the last page. Here we are asking the user to select the target variable. This list is pre-populated based on the input files provided by the user. Next, we are asking the user to select the performance metric. Though QuickDoK automatically documents all the relevant performance metrics for the use case, for example, ROC, accuracy, precision, recall, F1, F2. But through this field, we are taking the input from the user to understand which is the most important metric for this specific use case. For example, if the use case demands to reduce false positive, user can select precision. And if the use case demands to reduce false negative, user can select recall. QuickDoK anyway automatically documents all the performance metrics as per the problem type, whether it is classification, regression, anomaly detection, or any other. Here there is a list of all variables pre-populated from the input files. The user can choose to ignore variables which are not a part of the model file. This is the final step. That's it. Then click on Submit. Now document generation happens at the back end, and user need not wait here for the document to get generated. User can move from this page, and whenever the document is ready, the user can view or edit the document. Now the document is generated. Here we need to fill in actual target variable names to the encoded classes as extracted through encoded files. For this demo, we are giving some logical name to the encoded class 0 as good clients, and for encoded class 1s as in-debt clients. In a few seconds, we can view the document. The document is ready now. Let's click on View. We will briefly walk through all the components of this document, which is automatically generated. First is Business Challenge. This is based on the project details provided by the user. Then we have Solution Design, which describes the model used in this experiment. For example, in this demo, we used Gradient Boosting Classifier. So this section describes the same. Then we have Data Overview. This is for both test data and training data. Here it documents the most important features. Data Statistics summary of those features. It documents the correlation and interaction plots. It automatically generates the description based on the data upload, that is, which are the variables that are highly correlated and what should we do about it. It documents categorical variable distribution. It documents bivariate plots. The important part is it also generates an explanation for all the plots and the data. Then it captures the numerical variable distribution. The same components are documented for test data set as well. The next section is Model Overview. Based on the model uploaded, it will document the important hyperparameters. And what are the significance of those hyperparameters? It documents the performance of the model. Since this document is for a classification model, therefore it will document the classification-related metrics, that is, accuracy, F1, F2, precision, and recall. If the user is using, say, anomaly detection model, then it will also document Matthew correlated coefficient, which is one of the most important metric for anomaly detection. It also documents ROC plots. It explains the area under the curve for each class. Then it documents cumulative gain curve, talks about the advantage of this model over others, captures important features with its score, and partial dependency plots. Next section is Model Drift. Here the document is capturing data drift as it is required to be monitored as a part of production solution. This document calculates drift observed in test data set over the training data set using PSI values. Similarly, it also calculates the concept drift. Then there is Model Interpretability, where local and global interpretability are explained using shapely values. It is important to note here that all the values, text, graphs, plots, tables are automatically and dynamically updated based on the data and model file uploaded. If the user needs to add any customized text in the document, there are plus icons displayed after every paragraph on which the user can click. For example, in the beginning of the document, the user wants to add a section on team structure. When the user clicks on Add, it gets added to the document index. Once any iteration is run over any experiment, which I will show you shortly, the customized text remains intact for the new documentation as well. Now, let us look at how to add experiments in a project. There are two ways. One is iterate, and another is add new experiment. In iterate, data file remains the same as used in earlier experiment, just that user can choose to change model type and/or model file. After clicking on Proceed, I'll keep the same model type, but change the model file with different hyperparameters. Click on Update, and then iterate. Here, target variable remains uneditable, as for this dataset, the user already selected the same in previous experiment. Also, if the user wants to change the performance metric from previously selected recall, that is also possible. If this iteration has changes in variables, accordingly the user can select or deselect the variables populated from previous experiment. Then click on Submit. That's it. So in case for the same project, if the user needs to use a different dataset, then they can proceed to Add New Experiment. On clicking on Add New Experiment, it will take the user to the Solution Design page. Here the user can change the name of the experiment if required. Suppose for this experiment, the user chooses Random Forest Model with Scikit-Learn Framework and version 0.2.4.1. Then upload the data and model file accordingly. Fill in the data validations and then click on Submit. Meanwhile, the document is generating for the iterated experiment. Let us look at another interesting feature, which is Collaborative Tool, where any user can talk to any other user based on the access. For example, I want to ask user 1 to run another iteration, say with model GBM, on experiment 3. This way, any user can collaborate with any stakeholder for the projects. Now our iterated experiment is ready. Let us view this document. Here we can see that the changes that were made in the first experiment are reflected here too. Now let's summarize what we have gone through in this demonstration. We've seen how to create a project, how to view the document generated automatically, how to add customized components in the document, how to iterate or add new experiment in a project, and how to collaborate with stakeholders with a single collaborative tool. So this sums up our demo for QuickDoK. Thank you all for watching it.